There you go.
Here we go. Whoa! Now we got one here with a double factored problem. Because what we need to do is, first off, we need to write this a couple of different ways. First off, I'm putting each term lined up, and if I don't have it, I'm putting a 0 with it. Really didn't necessarily have to do this, but I think it helps explain it better. That's why I did. Now I need to write these out each factor. Well, this one, hey, factors of 9, 9 and 1 and 3 and 3, but 3 minus 3 makes 0. Factors of 3 are 3 and 1, and 3 minus 1 makes 2. Woohoo! Oh, Nelly, we got a problem on this one. These are the same. That means they're not going to be an asymptote. It's going to be something different. All right? It's going to be what we call a whole, because they can cancel out, yet you can't ignore them still. They cancel each other out as far as like, all right, all right, now then. So here we go. Well, let's still find the y-intercept. To find the y-intercept, I'm going to go to the one on the left. Negative 9 over negative 3 is 3. So the y-intercept is at 3, or 0, 3. I need to now find the x-intercept. And the x-intercept is found by setting the numerator to 0. Now, here's the problem. There are two values, but this, because these were the same, it knocks that one out. It knocks it out. So my only x-intercept is at negative 3. It is not also at positive 3, because that one got knocked out. So I have an x-intercept at negative 3, 0. All right? How do I find the vertical asymptote? By setting the denominator to 0. But remember, the wholes cancel out the vertical asymptote. So technically I have 2, but I'm going to cancel out that x minus 3 one. So my only vertical asymptote occurs when x equals negative 1 when I solve this one. So the vertical asymptote is at x equals negative 1. All right? And the reason this one's not an asymptote, I mean, I still can't have 3 as an answer, because 3 minus 3 does make this a 0 here, but it's not an asymptote because as this is approaching 3, it's also approaching it from the same exact values. That's why there's no asymptote there. All right? It doesn't approach infinity there. It's going to make a whole. And how do I find the horizontal asymptote? By the leading coefficient. In this case, they're both 1. So the horizontal asymptote occurs at y equals 1. All right? So, I need to look at the wholes, though. I do need to find a whole. The whole is, what is the common factor here? It was both x minus 3, x minus 3. So I'm going to kind of look at that without those on there a second and set that equal to 0, because I need to find the whole. The whole occurs when x is 3. So at 3, I will have a whole. So here's what I do to graph it. Here I have my graph. Let's put our vertical asymptote. Well, actually, let's put our y-intercept up here first. That's right there. Let's put our x-intercept up there at negative 3, 0. Let's put our vertical asymptote at x equals negative 1. And let's put our horizontal asymptote at y equals 1. Hey, man, this was really cool. Look, I already have my curvy lines. Except I can't have an answer at 3. At 3, I have a hole. So I make an open circle right there at that one. I make an open circle right there. And at that point, your graph comes there, it stops, and then it continues on afterwards. So you make a hole there. It says you cannot have 3 for an answer. Because if you have 3 in here, you will get 0. Because 3 squared is 9. Minus 2 times 3 is 6. 9 minus 6 is 3. And 3 minus 3 is 0. Makes that whole problem 0. It's not like I can just cancel it out and it goes away. The graph will have a hole. All right? So you have to check for holes, but they only occur when you have the same common factor. All right? So we added holes to our problem. They're kind of unique too. All right? You go ahead. Yes.